All right, guys, so the last thing we're looking at is solving. Last part of the review sheet we're looking at is solving these radical equations. So there are two sections with solving. One's just solving, one says solving, check your answers. On those, you're going to need to check your answers. Now, our main step for solving is one, is there one radical? If so, get it by itself. If not, even them out. 2, put both sides to the nth power. 3, if there are any radicals left, repeat steps 1 and 2. And then step number 4 is solve. So if we look at problem number 31, is there one radical? Well, yes. Get it by itself, it's already by itself. So at this point here, we're going to put both sides to the second power. Because on the left-hand side, the square root and square would cancel, telling us that 2y is equal to 64. There are no radicals left, so we can solve for y. And we can do that by dividing both sides by 2, telling us y is 32. That's it. Yes, sir. Yes. Yep. Yeah. Well, next thing we need to do is check 2 times 32. So we can check our answer, make sure this works. So we just need to plug it back in. Now with checking, the bare minimum of what you need is at least one showing that you plugged it back in for each variable. And then we can simplify it. The left-hand side, we can grab the calculator. Say second square root 2 times 32 is 8. So that's telling us 8 is equal to 8, which is true, so 32 is the correct answer. That's it. All we got to do. Questions on 31? Let's look at 32. Square root of y minus 4 plus 7 equals 15. Yes. So there is one radical, and we got to get it by itself first. So we're going to subtract the 7 first, because our 7 minus 7 will simplify out, telling us that we have the square root of y minus 4 equals 8. Now, since the radical is by itself, we can square both sides. And on the left-hand side, the square root and square will cancel, telling us y minus 4 is equal to 64. There are no radicals left. All right, guys, let's focus in. So we need to get y by itself. Add 4 to both sides, telling us y is equal to 68. And if we check this here, we're saying that the square root of 68 minus 4 plus 7 is 15. So we go second square root, 68 minus 4 plus 7 is 15 is indeed equal to 15. I can. Any questions on these so far? All right. Questions on 33 or 34, one of those that y'all want to look at. 33. 3 times square root of 2x plus 7 plus 27 equals 4. Well, the first thing we'd have to do here is to get the radical by itself. So we can subtract 27 from both sides. Telling us 3 times the square root of 2x plus 7 equals negative 23 is the radical by itself. We got to divide it by 3. Which will tell us that the square root of 2x plus 7 is equal to negative 23 over 3. Now is the radical by itself. Okay, so what can we do next? Because we got the radical by itself, so now we can put both sides to the nth power. And the nth power in our case is 2. Now the square root and square will cancel. 7 is equal to negative 23 over 3. Negative 23 over 3 squared is 529 over 9. Now there are no radicals left, so we can start solving for x. We can subtract 7. So 529 minus 7 is 466 over 9. And then lastly, we would divide it by 2. And we get 233 over 9. Now the last thing we would need to do is check. 3 times the square root of 2 times 233 over 9 plus 7 plus 27 is going to equal 4. And luckily we can grab a calculator and do 3 square root of 2 times 233 over 9 plus 7 plus 27. And this here should equal what? That equals 50. So that's telling us 50 is equal to so 233 over 9 is an extraneous solution. So that does not work. So that means, do we have any other solution besides this one? No, so this is no solution. And again, there's not going to be any no solutions on the test. There might be extraneous solutions, values that we have to remove, but there aren't going to be any no solutions. Any questions on this here? Are you ready for the next one? Questions on 34? Okay. Questions on 35 or 36? Because we can look at any of these here. I mean, we only have a few more left. 35. Is there one radical? No. If not, even them out. So we're going to have to add. Well, we could subtract if we wanted to. I would prefer to add the 9 through to 4x to both sides. Because if we do that, we have the 9 through to 2x minus 1 is equal to the 9th root of 4x. Well, they're both positive. It makes it a little bit nicer to work with if they're both positive. Now at this point here, we can put both sides to the nth power, which is 9. Those cancel. Those cancel. Telling us that 2x minus 1 is equal to 4x. Now we need to, well, we can minus 4x or we can. Yeah, there's nothing wrong with minusing 4x at this point. It would get negative 2x minus 1 equals 0. But the reason I'm going to subtract 2x is if we do that, we get negative 1 equals 2x. And having the x value positive is nice, but subtracting 2x, we now have the numbers on one side, x on the other. It takes one step out. And the last thing we have to do is divide by 2, telling us x is negative 1/2. Now we can check this one here and make sure this works, because I'm going to check it right here next to it just so we have everything in the same screen. If you want to check it below it on your paper, that's fine. Because we'd have 2 times negative 1/2 minus 1 minus the 9th root of 4 times negative 1/2 is equal to 0. So 9th root of 2 times negative 1/2 minus 1 minus the 9th root of 4 times negative 1/2 is 0. Yep. So x is indeed negative 1/2. Questions on this here? Questions on, well, we can go on and look at 36. So looking at 36, is there one radical? Is it by itself? Yes. So we can move on to step 2, put both sides to the nth power, and our nth power is 3. Cubed root and third power will cancel, telling us 10x plus 15 is equal to negative 125. No radical, so we can get x by itself. Well, we can solve for x. So we can subtract 15 from both sides. Well, negative 125 minus 15 is negative 140. Divide by 10. Almost. Negative 14. Cubed root of 10 times negative 14 plus 15 is supposed to equal negative 5. Cubed root of 10 times negative 14 plus 15 is, indeed, negative 5. Any questions on 35 or 36? All right. Question, let's go and look at 37. 37, we have the square root of 3 minus x is equal to x minus 1. Do we have one radical? Yes. Is it by itself? Also yes. So that means we can put both sides to the nth power. Now, the left-hand side is kind of nice. The square root and square would cancel, giving us 3 minus x. The right-hand side, the x minus 1 being squared, because we have two terms being subtracted, we're going to have to multiply this all the way out. So it's going to be 3 minus x. Here we're going to have to do x times x, which is x squared. X times negative 1, negative x. Negative 1 times x is negative x. And lastly, negative 1 times negative 1, positive 1. Negative x minus x is negative 2x. Are there any radicals left? No. Now, since we do have an x squared term and a middle term and x to the first term, we are going to have to get this equation equal to 0. So what can we move first? So we're going to add x, and we're also going to have to subtract 3. Telling us that 0 is equal to x squared minus x minus 2. So we can factor this here, 2 sets of parentheses with 3 spaces. Since the third term is negative, our signs are opposite. Factors of x squared are x and x. Factors of 2 are just 1 and 2. Which one's going to be positive? The 1's going to be positive, the 2 is going to be negative. I can check this here and make sure x times negative 2 is indeed negative 2x. 1 times x is positive x. And negative 2x plus x is negative x. Now we do have two things multiplied together to equal 0. So one of these is going to have to be 0. X plus 1 or x minus 2. And as we solve for both of these here, we find out that x is negative 1 and x is 2. Now this here is going to be one of the problems that's definitely going to show up with solving and having you check your answers. And again, when I say check your answers, especially for this here, so for negative 1. I want to, A, see that you did plug it back in, and we can simplify. Now, if you want to use the calculator, that's fine, because we can pull the calculator up and say second square root, 3 minus negative 1 is 2. Negative 1 minus 1 is negative 2. So we're saying 2 is equal to negative 2. Is that a true statement? No. So x equals negative 1 doesn't work. We can do the same thing with 2. Well, we go second square root, 3 minus 2 is 1. 2 minus 1 is So x equals 2 is our only solution. And really for the check step, this is really all I'm looking for. If you check it by hand, that's fine. That works too. Any other questions on 37? Questions on 38? We can look at 38. Well, we do have one radical, and we've got to get it by its self. Well, so far we do have a square root equal to a negative number, yes? So there's a good chance it probably won't work. But is the radical by itself? No. What do we need to do? We need to divide both. Negative 4. We need to divide both sides by negative 4. Because these will cancel, leaving us with the square root of 3x minus 11. And as we've seen so far, an even root cannot equal a negative number, yes? On the other side, negative 8 divided by negative 4 is? Okay, this will work fine because it's now equal to a positive. The previous one didn't work because once we got the radical by itself, it was still equal to a negative. Now at this point we can keep going. We can square both sides. The square root and square would cancel, telling us that 3x minus 11 is equal to 4. To solve for x, the next thing we can do is add 11 to both sides. 3x equals 15. X equals 5. I'll go on and check it just to make sure. 19 minus 4 times the square root of 3 times 5 minus 11 equals 11. 19 minus 4 square root of 3 times 5 minus 11 is indeed equal to 11. Even on the solving ones, if it doesn't ask, even if it doesn't ask you to check if you want to throw it in the calculator, make sure it still works, that is perfectly fine too, especially if you don't feel like the number is correct or your answer is the right one. Check it. Throw it in and check and make sure. It's an easy way to figure out if it is or not. Questions on problem 39? 40 actually won't be on the test. It was on some of the last test that I gave of this chapter, but I dropped it from this one. There is a bonus, it's just not 40. Yeah. Let's look at 39. There is one radical and we need to get it by its self. So we can add x to both sides. Telling us that the square root of 54 minus 5x is equal to x minus 8. Now that the radical is by itself, we can square both sides. Now on the left-hand side, the square root and square would cancel, telling us that 54 minus 5x is equal to x minus 8 times x minus 8. -5 We have to distribute through. X times x would give us x squared. X times -8, -8x. -8 times x is -8x. And lastly, -8 times -8 is plus 64. Now, before we start trying to solve for x, it might be good to combine like terms. Our negative 8x minus 8x is negative 16x. Now, we do have a squared variable and a variable to the first power, so we'll need to get this equation equal to 0. What can we do first? Yeah, we can add 5x, telling us that 54 is equal to x squared minus 11x plus 64. Subtract 54, telling us x squared minus 11x plus 10 is equal to 0. X squared minus 11x plus 10 equals 0, so we'll need to factor this here or graph it. Since the third term is positive, our signs are the same and match the sign of the middle term. Factors of x squared are x and x. Now the factors of 10 are 1 and 10 or 2 and 5. Which factors do we want to use? 1 and 10. Those are the only ones that will get us to 11. Since we have x minus 1 times x minus 10, now either x minus 1 is 0. If that's the case, the value of x is 1. Or our x minus 10, and it will tell us that x is equal to 10. So our two solutions for this here are 1 or 10. Now with this one here, we do need to check and make sure that both of these work, or at least one of these works. As we check this here, so we'd have the square root of 54 minus 5 times 10 minus 10 is equal to 8. At this point, we can just grab the calculator and say 54 minus 5 times 10 minus 10 is equal to negative 8. And it was supposed to equal, yep, negative 8. So that works. You can also check 1. Second square root 54 minus 5 times 1 minus 1 is the 6 equal to negative 8. No. So the only solution that works for this here is that x is equal to 10. Questions on 39? Do you have a review sheet? Okay. I'm not going to focus on 40 because it's not going to show up. It's not that it's hard, it's just decently long. Just a lot of steps, a lot of steps. Questions on 41 or 42? Negative 6 equals negative 6 times the square root of negative 9 minus x. There is one radical, so we need to get it by itself first. And we could do that by both sides by negative 6. Our negative 6 and negative 6 would simplify out, leaving us with our square root of negative 9 minus x. Negative 6 divided by negative 6 is 1. Now that the radical's by itself, we're going to put both sides to the nth power. We're going to square it. square root and the square would cancel, telling us that negative 9 minus x equals, solve for x. First thing we can do is 9. So that tells us that negative x is equal to 10. Now we need to get x positive, so we could either multiply by negative 1 or divide by negative 1. Telling us x is equal to negative 10. Well, we have a negative x value and a square root. So it might be good to check it and make sure. Well, we can do this calculator. Negative 6, second square root, negative 9 minus negative 10 is negative 6 does indeed equal negative 6. Questions on 41. Questions on 43 or 44. There is one radical, we need to get it by itself. So we can subtract 6 from both sides, telling us the 6th root of 9x squared plus 49 is equal to negative 2. Is the radical by itself? Can we have an even root equal to a negative number? No. So this here is, yeah. Yeah, because if we didn't catch it, I mean, we could keep solving. 6 root and 6 power. Negative 2 to the 6 would be positive 64. To get x by itself, we'd subtract 49. Telling us 9x squared is equal to 15. 9. And when we divide both sides by 9, 15 over 9 is 3/5. Lastly, we'd have to take square root of both sides, so this x is equal to plus or minus, because whenever we square root both sides, we have the plus or minus. Now, we will simplify the square root of 5/3. I can't leave it with a fraction inside. But the square root of 5 over the square root of 3 is the square root of 15 thirds. Bottom of a fraction. But square root of 15 thirds, it's not that it's wrong, it's not a bad answer. When we plug it back in, 9 times the square root of 15 over 3 squared plus 49 is plus 6 equals 4. So the 6th root of 9 times second square root of 15 over 3 squared plus 49 plus 6. It gives us, yes, 8 is equal to 4. It's not true. And if we do the same thing with the 6th root of negative square root of 15 over 3, squared plus 49 plus 6 is equal to 4, we actually get the exact same statement. Because our negative square root of 15 over 3 squared becomes positive. So neither one works. Any questions over any of this here?